So can you hear me all? Okay. So again, good afternoon. My name is Jhon Arias, and I'm going to present environmental challenges on the moon for solar panels. My mentor or instructor is Professor Malgorzata Marciniak, and our institution is LaGuardia Community College. So what is the project about? In previous research, there has been mathematical models done to maximize the efficiency of solar panels. So also, for example, there were done calculations and the shape or geometric. So there were different shapes. So there's like plane, there's cones, there are like donut shapes, and depending on that, the solar panel could be more efficient on the moon. It could track the sun better. So for this project, actually, the objective is to understand the main environmental challenges that those solar panels will come across. And we'll try to find plausible solutions to those. So the first one is exposure and dust. So it takes the sun 2 weeks to go from horizon to horizon on the moon, while it takes only 12 hours to go on Earth. So because it takes the sun to go from horizon to horizon on the moon 2 weeks, it also takes 2 weeks to the sun to show up again. So it is basically 2 weeks with sun and 2 weeks without sun. So like you could make the argument that it is 12 hours on Earth, but it is basically the whole month. So those 2 weeks or those 4 weeks in the Earth is going to be sunny. Let's say just making a supposition, not taking into account the stations or things of the sort. And so we made the calculations, the hours that our solar panel is exposed on Earth and also on the moon is basically the same. It is around 336 hours. So basically the question comes of why put it in the moon if it is basically it's going to be exposed the same time on Earth. But there's where comes the next thought, and is that the moon is cloudless and there is not atmosphere. That's why it's a better choice, because in Earth we have to suppose that there is no clouds. We have to suppose that wherever the solar panel is, there is not going to be let's say there are no stations, there's no winter, there's no fall, and there are no clouds, that's very difficult. So that's why it would be better or more efficient to put solar panels in the moon. But also there is another problem, and is that because the moon is cloudless, there's no rain. And if there is no rain, then the dust is gonna get into the solar panels. But not just that, the dust that falls in the solar panel is charged. So it could actually affect the functioning of the solar panel. So that's another problem that we have to search on, and it could actually affect how the power plant is going to work. The temperature. Well, the swings are very heavy and extreme in the moon. In daytime, the temperatures can boil to 120 degrees Celsius. And nighttime, the temperatures can lower to around minus 130 degrees Celsius. The temperatures are very extreme. And in some places, which is the craters, so we can all look to the image on the right-hand side. Do we see it, the orange ball? Those like blue dots, those are the craters. And those places, some of them are so cold to minus 250 degrees Celsius, which is the lowest temperature we have detected on the solar system. So it's extremely cold. And also we have the solar pole, the north and south poles, which are the places with more water, but at the same time, they're colder than the habitual temperatures of other zones. So they're not as cold as some of the craters of minus 250, that's too much, but they're still a little colder than the habitual temperatures. Even though there's water in them, still we need to find a way to go about it. There is also the lunar reconnaissance orbiter. It orbits the moon every 120 minutes, and it observes how the lunar surface heats and cools over a day, which we can see also in the right-hand side on the bottom. That's how basically the image, how it looks, the camera of the lunar reconnaissance orbiter. And also it distinguishes high amount of rocky material around the moon. So because of this, it has been found that there had throughout many or several, well, billions of years, there has been several impacts of meteoroids on the moon, and that's why all the pieces or all the rocks has divided in very small pieces. So what this suggests is that meteoroids are they're very common in the moon. They're very habitual. They happen very often. And the head of the NASA of I think that's his name here, Bill Cook, which is the head of Meteoroids Environment Office in Alabama. He basically made a rough calculation of around 33,000 meteoroids per year. So that's another problem because it could destroy the solar panels, or it could also redirect the solar panel, and it destroys the functioning there. And for the discussion, so a solution that we might have for the first problem of the dust is to maybe send robots that could spread water. So we don't have the rain, but we could have small robots that could actually spread water, and well, that's a way to basically clean the panels. But also we need to find a better solution because again, the dust that falls is charged. So we need to prevent the dust to fall on the power plant in the first place. And also for the temperature, we could use a vacuum that could, for example, on the daytime that is very hot, the vacuum can absorb all the heat, and later on nighttime that is very cold, it can release that heat within the power plant. So there's not extreme, it kind of cancel out the temperature, so there's not extreme temperature. And also in nighttime, it absorbs the cold, and later when it is daytime, it releases it inside the power plant. So again, no extreme temperatures. So these are some of the references that we use for the whole information of this presentation, and also for the images that we used. And thank you so much for your attention. And if you have any questions or anything, feel free to ask.
Thank you. Unfortunately,